Generative AI and large language models are becoming popular for very good reason. There's so many different things that you can do with them, from reading and reviewing documents to creating different text or images. And one thing I don't think has been explored enough is how you can actually use a large language model to actually go and query data against your database. Now, traditionally in a large language model, you can feed it different documents, but how can you feed a large language model millions or billions of rows and then expect it to query against that data in an efficient way? So that's exactly what we're going to do today. We're actually going to take a look at how you can use a large language model to query against a database. And we're going to explore that through two different data sets. The first one is from every different shot or basket that's been recorded in the NBA from 2001 till 2022. And then we're also going to take a look at 311 calls in New York City. These are two popular data sets that have not massive data, but I think a good chunk of data in them, so we can kind of explore how to do this. And then from there, we're going to be using DuckDB. We'll take a look at how you can integrate that with LLMs and a Python package called LangChain. And we'll take a look at how you can actually do that with a new tool that's been recently released, which is called MotherDuck. It's a serverless online version of DuckDB that allows you to query against a database in the cloud or a database that you created locally. So that's what we're going to do today. So with that, let's jump in. Hey everyone, before we get to the rest of the video, I want to take a minute to talk about SetApp. SetApp is a tool that I have been using that is a platform for multiple different Mac apps that solve a lot of pretty unique problems, and I've actually found really useful. Now you may be wondering what sort of tools I use to actually do these recordings and screen recordings. The one I actually use is called CleanShot. It allows me to do these video recordings, but it can record GIFs, screenshots, allows you to annotate them. It's really changed everything that I do when I'm creating. And that's actually one of the over 240 plus applications that you can actually get and access with a monthly subscription to SetApp. There's a number of these applications that I've found really useful and I've been using regularly since I started using SetApp. There's Canary, which is a mail platform that allows you to summarize your conversations with AI and actually send emails with AI as well. Another one is Bartender. I could never really figure out what that bar was at the top of my Mac that had all those icons in it. This basically allows you to organize that and keep some visible, some not, add spaces, so on and so forth. Another one is Mosaic that allows me to manage my desktop really easily and drag windows so I don't have a bunch of clutter on my desktop. I've also been using Speakio that allows me to get coaching and feedback on my public speaking whenever I'm on a Zoom or a Google Meet, and it actually records it and gives me tangible feedback that I can actually use to change my public speaking habits. And finally, I use Clean My Mac to actually get rid of clutter or files I don't really need on my Mac. I don't do a good job on this, so this has really helped me reclaim some space on my computer. If you're interested in checking this out, you can click this link or find the link in the description. This gets you 7 days access and supports this channel at the same time. Give it a shot, test it out, and now back to the video. All right, so let's get to it. Here is the notebook that we are actually going to be working against today. I did this all in Python because for two different reasons. One is DuckDB can easily integrate with Python, and then the second is that I can actually use this Python package called LangChain. Now, LangChain allows you to wrap around and use multiple different LLMs that you might want to choose from. Of course, the most popular, I would say right now, is OpenAI and GPT-4 or any of the previous GPT versions, but there are so many different ones that you can use. Of course, all of those come with some certain setup or things you might have to do with that. Now, as a very quick tutorial on LangChain, there's some really great videos that go deep into that. I'll actually link one somewhere up here in the video, so you can take a look and check that out. But there's a lot of different things you can do. There's this ability to connect different models and different LLMs. So you can see there's lots of different choices here, so you can choose from any of these that you might want. You can work against the Hugging Face hub. If you're not familiar with Hugging Face, I would definitely check it out. It's sort of this repository, I guess in a way, of all these different data sets and different models that you can use. So you can actually check in and see which ones are being popular or not, and right now there's about 260,000 as of this video. So once you've chosen your model, there's a few different pieces that you can do. You can create chains, and you can actually chain together different prompts. So if you have 3 prompts in a row, that would be what a chain would be. You can attach some sort of memory to your LLM so it can remember some things in context. And then you can actually create an agent, which is what we're going to do today. So this is probably the most familiar thing that you will have with an LLM is if you're considering ChatGPT, you can ask it a question, get something back, and kind of have a conversational chat, and it can remember and store some of that information. The other piece that we'll take a look at is actually creating a prompt template. So we'll actually structure a prompt that we want to pass in to the LLM. It's pretty simple. It's literally just like constructing some text and then putting in some parameters. Ours is pretty simple, but you can start to see, at least from this, how it can start to get more and more complex. So that's the first step of what we're going to do. We're going to get started and just get our installs up and running. We'll install LangChain and OpenAI. You'll need to set up an API key with OpenAI. So the reason we're using the OpenAI API is that you might have to pull down a pretty massive model, and these models, depending on the size, are not small by any means. You'll have to set up some GPU on your machine, and depending on the model type, it may or may not work as good as ChatGPT. I totally think you can use a model that you want or create your own model if you so chose to do that here. So there's nothing against doing anything like that, but at least in this case for this tutorial, this is probably the fastest way to get started. That being said, there's tons of models that are being created. All are growing at a rapid rate. There's literally so much happening in the space. I've kind of found it hard to keep up. So I think this is one easy way to get started, and we'll kind of look at how this can work against a really massive general model, right? Let's keep that in mind. It's not trained specifically on our data, and it's not specifically trained on the questions we're asking. So, it doesn't know we're going to be talking about SQL. It literally knows nothing until we ask it that. So just keep that in mind as we go forward. All right, so let's get through the rest of the imports here. What I'm going to go ahead and do is just import all the things we're going to need from LangChain. I'll put this notebook up so you can actually test that out. Obviously, it won't have an API key. You'll have to grab one of those on your own. And keep in mind, you may have to enter a credit card even to get the free billing details. And keep in mind, you may have to give a credit card number or some sort of payment to get access to the API, even if you're below the 3 credit threshold. But once you go in, you can actually set a threshold to say don't spend any money or anything like that. So just keep that in mind. So once we have our imports, we're actually going to install this version of DuckDB. There is a more recent version as of the time I'm recording this. But since we're going to be using the spatial package, it works best currently with this version, but I'm sure other versions in the future will work just fine. So we're going to go ahead and install that. I actually have run this before, so it's already installed. And then just double check we're in the right version. Okay, great. So let's fold this up and get started here. So I'm going to import DuckDB. And then I have one more install, which is this DuckDB engine. So since LangChain basically takes a SQL Alchemy database, to actually use that and this specific database here, we're going to want to install this DuckDB engine package. So once that's installed, we can pass our DuckDB database that I've already set up. It has this NBA data in it. If you want to take a look at the data that's right here, so this is the NBA shots data set from 2000 to present. It's actually not to present, I think it goes up to 2022. And there's a lot of data in here. There's some information about the match ID, and we'll take a look at this in a minute, but it basically has kind of every recorded shot taken during this time period. Now, I don't know if this has been updated recently, but you can see all the data here and actually get access to it. And it stores it across a lot of CSV files. So I think there's all of these plus 4,400 more. So if you wanted to dump this into a normal, just single data set, you'd be doing a lot of work here to kind of do a massive set of inserts or anything like that. What works great about DuckDB in this case is that I can actually just pull all this data down and then query a wildcard against a directory or a folder on my desktop. So I don't actually have to write anything else. I just write star CSV and it will compile all of those into one single table, which is awesome. So let's go ahead and get started. We'll connect it. We'll connect to our database here, and we'll describe our table, which has all this information here. And as you can see, there's a bunch of stuff that we're probably not going to use. We're going to drop some data here, these unnamed random columns. And there's some other stuff that we have to put into it because we don't actually have a date of the match itself. So here's what one row looks like. And as you can see, once we query one row from our data set here, these columns are effectively just a repeat of the same ID over and over. But then we have this match ID, and you can see here that there's 2009, which is obviously our year, 05, which is our month, 22, which is the day, and then Cleveland, which is where the match is taking place in Cleveland in this case. And then you have some information about the time remaining. If it's in the first quarter, there's a sort of a coordinate system that matches up against the court. You can see who made the shot, who they're playing for, if it was made or not, the shot type, distance, the score, and then the opponent. All right, so this is against Orlando. The status is tied at this point in the game. So there's a lot of data that we can work with here, but we're actually going to update and modify it a little bit. So first is we're just going to create a new table from our data set, and it's going to be called NBA short, and we're just going to get rid of those columns. So I'm going to select everything, I'm going to exclude those 3 columns that I don't want, and we'll do that. I got an error because I did this already, so that makes total sense. And then what we'll do here is actually alter the table. We're going to add a column called match date with the date, and then we're going to pull off that match ID and take the first 8 characters from the left. So that's the year, which is 4, month, which is 2 digits, and date, which is 2 digits. And then we're going to pass it in our format here, year, month, date. This is the function in DuckDB to set up the time, and that's all we have to do there. So now we have this new table called NBA short, and we can pull just the columns we need and not confuse the LLM we're going to use or the GPT model because all these extra columns that might look at them and say, is this something I need to know, yes or no? All right, so I'm going to close this up as well since we're finished there. And then this is where we start to get into the LangChain and setting up for the LLM. So it's actually only a few steps. The first is I'm just going to create a SQL database from a URI. That's that DuckDB URI that I set up in the cells above. And then what I'm going to do is I'm going to include the NBA short table and then allow it to sample rows here. Now there's tutorials to do this on the LangChain documentation. So if you go into agents, toolkits, and all the way down to the SQL database agent, this is some of the code that I actually pulled in to use here. So you can take a look at all of this if you want to start from the source, as it were. So let's go ahead and set up our database. You get that indices sort of error. It's not going to cause any problems. It's just saying that it can't support indices in a DuckDB database yet. We're going to set up our toolkit, which is linking to our DB above, and then the LLM, in this case OpenAI, and those are all imported from above. Set that up, and then we're going to basically set up our agent executor, which is the agent that will execute our text prompt for us. So you have this SQL agent, create the agent, there's the LLM, toolkit, which is above, and then the agent type. And this is the one that was recommended in this case. There's different types you can choose, but at least for our purposes. Now here is where it starts to get into the prompt engineering, as it were, and I know this term can be kind of verbose and mean a lot of different things to different people, but this is what we're going to do today. So our template will actually pass in a query here, which we'll type below, but I've provided all this other information that you can see. So this year, a SQL analyst that's querying a database of NBA shots that record data about every shot taken in the NBA. This is a description of the data types, and I just basically wrote this out and explained exactly what each thing means. Now, it will query the schema of the table, but I wanted to tell it what's actually happening here, so it's a little bit more implicit. And this is kind of just something that I think is important to do to really be clear. As I was playing around with it, it could get a little unclear at times, and we'll take a look at what that looks like in a different one, but at least for this case, that's something to do. Now, you may or may not have to do this every time, but it's just to be clear. Now, the other thing that I found that was a problem here was that it's by date, right? There's no reference to the season, which is really what matters. Like, I don't necessarily care how many 3-pointers were made in all of 2009, because that will include the end of last season from January to June, and then the beginning of the next season, which is October till December. So I tried to provide it here, and it actually did a really poor job with figuring this out in terms of what the season was. It really kind of broke the whole thing, so it's kind of difficult. So this sort of speaks to like the value of having good data. It's certainly something you'll want to do, is like provide the best data possible, and almost to the value of data engineering here too. Especially with your own data, you want it to be clean. You don't want any other stuff in it. You just want the things that you care about a little bit. So I tried to perform at this. It didn't perform great. We'll take a look at what that looks like. But then basically it passes in here to the query. And then here's the function actually when you have your prompt template, and then your agent here. So let's start with something really simple. How many points has LeBron James scored? Right, and we'll just ask it this, and you'll see it's starting the process here. And what I like is you can actually see an observation of thought. I should query the schema of the NBA short table to see what columns I can use. So it takes a look at the schema and the table, which is basically what we did above, right? What data is in there. And you can see here I should query it to see how the total points by LeBron James. And here's where things get rough, right? With this date component, it's actually trying to use that prompt of what it is and trying to query it against the dates, and then you get this thing that says he scored 0 points. So this actually didn't help at all. So what we'll do is we'll go through this whole process again. We'll go through how many baskets has LeBron James made. I'm just going to change up my prompt a little bit, and we're going to actually go here, and it says, okay, I should query the database for the number of baskets made by LeBron James, and select count star from NBA short where player equals LeBron James, and perfect, that looks great. And then final answer, he has made over 16,000 baskets, which is great. And I like that it returns this sort of text-based prompt for you. We can get a little bit more complex. So let's ask an aggregate query, add some where components into it, and see what it comes back with. So who scored the most 3-pointers in 2015 with at least 100 shots attempted? So let's see what that looks like. So who scored the most 3-pointers? There's this column, if you remember, that says the shot type, which is the 3-pointer there. And then it says that Steph Curry had the most 3-pointers in 2015 with 435 shots. Now, once again, remember that this is the problem with this is looking at the whole year of 2015. If you can see here, it's between the start and begin there, uses, and this actually returns a pretty complex query. So player count as num 3-pointers from NBA short where shot type equals 3-pointer and made equals true, and match date between 2015 here, grouped by the player having count grow over 100, and then num order by, and then limit, right? So that's what we get back, and we can see it came back with Steph Curry, Klay Thompson, and so on and so forth. So I did a pretty good job of all of this. I've been impressed consistently with what comes back from using this, and once again, it's from that API, so I don't have to have all of the GPUs and all the extra stuff running on my machine. Certainly, like I said, you could if you want to try that out and test it with your own model and tweak that. There's certainly time for that, but really what I want to do is explore how it interacts with the database, and that's what we're trying to do here. So we'll come back to this data set in a minute, and we'll actually test this out with geospatial data here. So what we're going to do is basically install the spatial library. If you're not familiar with DuckDB or the spatial library, it's just another database, but I think it's fairly unique in terms of the other spatial databases that you might be using. So DuckDB is something that is non-dependent on any other code. You can install it. It can read files locally on your machine, and it's designed to be an online analytical processing database, or OLAP, which is very fast for aggregates and lots of larger data samples. And when I'm talking large data, you can have, in terms of size, millions of rows, anything like that, right? You can have pretty substantial data sets. And this blog post is great to check out. It kind of talks about what is and is not in the library yet, but it's now been, it was a unsigned extension. Now it's actually a core part of DuckDB. So all I have to do is run those two commands here, and then I can actually set that up. So I'm going to pull this data in, and I'm going to, it's the NYC311, it's not the full 33 million rows, just a sample of that, and then you can actually, I'm going to exclude the incident zip because there were some data problems that I was causing there with empty rows and strings and things like that. So, all right, so that is all complete finally. It took maybe a minute to run here on my end. But then what we'll do is we're going to actually create our geometry and update that. So what we'll do is add that, and then we're going to use something that should look familiar. This is st point from longitude, latitude, and we'll go ahead and create that. And that should have a proper point geometry. Now what we're going to do is also add another table here of New York City neighborhoods. This is a great data set. There are official neighborhood boundaries from the city called neighborhood tabulation areas. I think they don't really reflect accurate neighborhoods of New York City. So I actually like this file a lot more. This is put together, and anyone can actually use this. This is actually put together by Tim Keeley, and I think he did a really great job of actually creating what most people consider the neighborhood boundaries. And this is, I think, for some real estate purposes, but you can see it gets very specific here in terms of the different neighborhoods and where they are and things like that. So thank you, and I keep using this file again because it definitely affects my understanding of the city more than the official NTAs, as they're called. So what we'll do is we'll create that, and you can actually, I'm going to select all the columns and then use the geom from WKB. That is what DuckDB reads it as is a well-known binary into a proper geometry in the database, and then it's from this stRead function, which allows you to pull in lots of different data types from GDAL and things like that. So let's go ahead and run that. And then I'm just going to create this table of NYC311 short with just a lot less data. There's a ton of columns in there, and what was actually happening was the number of tokens that the OpenAI API used was sort of stopping. So I'm actually going to just give it a few columns because it was trying to read all of that data. So we'll do that. This will probably take a little bit here. Okay, we're done. And then we're just going to do the same thing we did as above. So we're going to create our new spatial database here, our toolkit, and our agent executor. So what I did here is, once again, your prompt, basically saying I'm a SQL analyst, have these two tables, 301 calls and neighborhoods. They both have a geometry, where you can use spatial functions commonly found in PostGIS. So DuckDB doesn't support everything that's in PostGIS. I don't think anything supports everything that's in PostGIS, but at least I'm giving it a framework of reference to, because that LLM GPT will know things about PostGIS, so at least gives it a frame of reference. So the first thing I want to do is how many 311 calls took place in Stuyvesant Town. It's a neighborhood on the east side of New York City. So let's go ahead and run this and see what happens. So I'm giving it two tables this time, as you can see up here. It's going to create that schema for both tables. Here's the NYC 301 and the neighborhoods. Let's see what its next thought is. I should use the geometry columns to perform a spatial join, which is pretty cool, and it does it here. Look, we have the count from NYC short, join it on ST intersects, and where the neighborhood is Stuyvesant Town. So it did a good job. It wrote a spatial query and was able to execute it and return text for me, which is pretty awesome. I can start all the way up here with just a simple question or thought, and then end up with something all the way down here to see Stuyvesant Town. So let's try it again. I just want to see how many 311 calls about, let's give it something specific here, graffiti took place in the West Village and within 1 mile of the West Village. So I'm curious to see how it handles this. You use a few ways you could do this. You could use std within or stbuffer. It really doesn't matter. Let's see what GPT gives back to us. So it's going to go, once again, kind of go through that chain of looking at the tables. It's going to go through the thought, and it's going to say, all right, so let's see. All right, this is pretty good again. Select count from NYC 311 join on std within NYC 311 and a mile of where complaint type. So I think it actually got close, but not perfect, because it was within. So it only took the calls that are within 1 mile of that boundary. So let's just test that theory out. And took place in the West Village. So we'll go here. So yeah, I got 54 on this, and it did a decent job, I think, but in our original example, it didn't do the right thing. It didn't get all the calls that are in the West Village and within 1 mile. So that one was a little bit more complex. I'm sure we can do a lot more here to explore nearest neighbors, but I mean, honestly, I just wrote text. I was able to perform a spatial query and get data back, which is really cool. So all in all, I'm pretty happy about that. I think it did a nice job. So the other one that we can use is MotherDuck. Now, I mentioned that this is in a beta release, but what I love about this is I can actually use the cloud system, plus I can also use the local data on my database. So let's open a clean terminal. Let's clear this out, and we'll start up DuckDB with our simple command here. So let's go ahead and run through this. I can install MotherDuck, load it, and then open it. It's going to allow me to authenticate here and confirm that this is what I'm seeing down here. And easy enough, I just hit confirm and I'm ready to go. So now MotherDuck and my local DuckDB database are all set and ready to go. So that's all set up. Now what I can do here is I can show my databases, and you can see I have this set up already in my DB, NBA, and sample data, and this is all I had to do here, right? So I created my data set NBA, then I decided to use that database, which is using it from MotherDuck. So create it, then use it, and then I just ran this create or replace table, and then select star from NBA Parquet, and then this is the folder schema. So I'm saying select every folder in there, which is separated by team, everything in there, which is separated by year, and then every file within that. So I used a Parquet partition, which I actually created through MotherDuck to make it even faster. So it was pretty quick to load up, and I did that. All my data is right here. Now I could query this data in the user interface or in my local command line, but we'll just go with it here. So let's set it up. We're going to use my database here, and then we can go ahead and use these prompts that they just released. So they have these AI features to query data. So the 4 things you can do: you can answer questions about your data, you can generate SQL, you can clean up and fix your data and understand some things about your database. So that's already built in, right? I don't have to do any extra work, it's just there. So I can do this. We can ask it, did Michael Jordan make or miss his final shot? And we'll go ahead and ask it that. And we should be getting back that he did not make his final shot. Now, I'm trying to find the actual video of this, but from what I understand, his final shot was actually taking a free throw, which is not contained in this database. He made a free throw, which I'm assuming he was fouled on a shot, missed it, and then made a free throw. I cannot confirm that, but I was trying to find a video of that final shot. But keep in mind that this is when he played for the Wizards and not the Bulls. If you remember, he actually made that switch. So if you're thinking back to that famous shot in the finals, that's not the one we're talking about here. And unfortunately, because this data doesn't go all the way back to 98, I can't actually check that and ask that specific question of it. But we'll see here. So we're going to call prompt SQL, did Michael Jordan make or miss his final shot? And this will actually generate the SQL for us, right? So it says here, select made from NBA short, where player equals Michael Jordan, order by match date, descending, and limit. So that's the SQL that's effectively powering this. Now this does the whole thing for you. It doesn't return it as formatted text or anything like that, but certainly works great here as well, which is really great. And I can also call this locally, so I can go back and forth between the two and have the power of the cloud plus the local components as well, which is really awesome. So let's ask some other questions and see what comes back here. And we can ask that here. We can ask the same question above and kind of compare results here. So we'll do this up here. So we can see that the max distance was 38. So, and then finally, let's just ask another question. Who is the most efficient shooter with at least 500 shots taken? And we'll go ahead and run that SQL here. I kind of like using the SQL because you get to see what's happening under the hood. So you can see select player, case when made, then one else there as made shots, and then some as shooting percentage. So let's see what we get back when we actually run this here. We'll drop that in and run it. And it looks like it's, for some reason, it's telling that this person made all of their shots, which seems impossible. I don't know if they actually made all those shots, so let's just expand this. What's nice now is I can actually go and say, give me all 20 players there. So looks like we have Robert Williams. This looks a little bit more realistic. I don't know why this data set has Nene making every single shot he has, but you can see here a bunch of Robinson, Daniel Gifford, so you can see all the sort of overall shooting percentages. Now, for some reason, these percentage mains, it seems really high. Let's just take a look and see. And according to Google, he has a 0.712 shooting percentage, which is pretty good. Let's go see and make sure. Yeah, 0.72, so it might be rounding up there, but I mean, man, that's pretty cool here. So you can actually see, here's the shots taken, made. Wow, pretty cool stuff. What about by three-pointer? Let's just ask. So who is the most effective three-point shooter? We'll copy that over and try this one more time here. So yeah, okay, so that's what it is. So it for some reason put in 3 point. I think that is the correct. And it's limiting by distance too, so it added like a little bit more than we needed here. Let's try this and see if we get something back. So yeah, okay. So there's these weird ones in this data. Obviously, this isn't perfectly clean. So let's go ahead and move this out to the top 30 players and see what we get back. Okay, so here's, yeah, now okay, so seeing this now that it added in the ability to make true. And see here, of course, as we think, Seth Curry is the most efficient. So it kind of over-engineered some of the SQL, which is okay. We can always go back and fix that and figure that out. But yeah, you can kind of see who the top shooters here are across this data set, which is pretty cool, I think. So once we modify that SQL, I think as you can see, there's a few things that it kind of over-added here, and maybe that was due to my prompt. I could obviously adjust that, and there's, I could certainly add more text to that. I'm really just asking it the bare bones question, but as you can see here, we actually see that Seth Curry, not Steph Curry, has the most efficient shot at 3-point percentage, along with a few other folks here. That's Steph Curry's brother, who has I believe he broke the record for most 3 points scored. But if you want to just filter this out, let's say we just want to look at the top shooters. I love this about MotherDuck, because I can just quickly drag this, and I can see, okay, people have shot, over 4,000. You can see who the top shooters are here, and the percentages are pretty close. I mean, it's kind of the top shooters are pretty consistent, only within a few points here. But it's just fun to look at data this way and ask some questions. So yeah, I really love what MotherDuck's done here. I can have my local data, cloud data, everything in between. So that's really awesome. All right, to wrap up, can you query your data using an LLM? And I think the answer is yes. Now, how accurate that is depends on a few factors. First of all, how clean is your data? Did you do a good job of preparing it, putting the right data types in? For example, the NBA, I need to add the season, so it actually could query against the season rather than the year, which really doesn't matter in the context of what I might want to ask. Some other things that you want to make sure you have is you limit the amount of data. You don't need all of it for every single question, so keep that in mind. The more you throw at it, it's more likely that you could confuse the model rather than help it. So that's something you want to do as well. You also want to kind of limit the amount of questions you can potentially ask, right? It'd be really hard to scale